Okay, so it should be, yes, okay, we are back. Okay, great. Okay, great. Okay, so yeah, that was this kind of thing. Something like that happened previously on YouTube that was impossible to recover. So we have many problems like that in the past. So anyway, let's continue with the situation. So I understand that you heard my answer. Okay, I can see now on the chat. My chat was also it was also frozen, so I couldn't see the chat. So thank you. So let's continue. So we have now these all those robots here on the simulation, and very good. So far so good. I mean, here there are, and I'm going to show you. Here is a wall. Here the 3 robots, and yeah, what else? So the whole environment. Okay, so let's continue now. Here is how to launch it. Then first thing is we need to prepare all the gmapping files. So we already have the gmapping prepared because what I mentioned to you. So so we were preparing, trying to find this error, and we didn't have the time to solve all the problems. So everything is already ready for testing now. So it is here, all the packages that you're going to need today and to create. You don't have to create because they are already created, but I'm going to explain you how they work. So you can find all the ROS programs in the Catkin workspace, that is here, and then source. And we are going to go to some of those packages, the ones that are related to the class of today. Then what do we have here? Okay, so first let me show you here. Okay, so this is the move base, but this is not the one that I want. This is from a previous live class. This is the multi-robot exploration that I'm going to talk you afterwards. And here, let me see here. This is not the one. This is for RRT, that we are not going to do it today. And here we have all the main package, launch files that we are going to use for launching, as I mentioned, the move base for the robot. So that move base for each robot is going to allow us to send goals to the robots to move autonomously with the move base. So the robot will move around. So we have 3 launch files, move base 1, move base 2, and move base 3. Each one is launching the move base package for each robot. And then at the same time, we are launching the G-mapping algorithm for each robot. Also, it's configured. This launch file is configuring the G-mapping for each one of the robots. That's what we explained on previous live classes. So in this main launch, what we are doing actually is launching everything that we need today for this purpose. So let me show you. So this main launch that is included inside the Turtlebot RRT exploration inside here. So this is this main launch. The other main launch, I'm going to close it. Wait, is this one? Yeah. So the previous main launch, I'm going to close it, not to confuse. So this main launch inside the Turtlebot RRT exploration is the one that is launching the G-mapping for each one of the robots. And then it's also launching the merge of the maps, but let's not talk about that right now. And then is launching the move base packages for each one of the robots. Finally, is launching the RBase, so we can see the different maps in RBase with a specific configuration, so you don't have to bother into adding another map and configuring and etc. So everything is done. Okay, so I hope that you understand those launch files, and except for the map merge. So let's launch it like this. So let's do one thing. Let's comment this map merge. So here you can comment this, the map merge, and then let's launch just the G mapping and the move base and the ROS. Okay, so once you comment this, so I have cut the comment here and put it there, then let's open a shell, a terminal, and then launch this map.launch. So for that, go to tools, then select shell, and here you can do a ROS launch. And what is the package where this main launch is included is called turtlebots underscore RTT exploration, and then main.launch. This is just an example, okay? So then if you launch this, you will be launching, I repeat, G mapping for each one of the robots that we have in the simulation, and move base for each one of the robots. That means we can move every one of the robots independently, and each robot is going to be creating a map independently. Okay, so let's have a look at that. Let's have a look at that. And by analyzing this, you are going to see something that is quite interesting, that is the TF. How is the TF created for those systems? Okay, so here you can see that the algorithms have started. So now we can see on ROS how is the map being created. So for that, let's go to these tools and then select the graphical tools. In order to see ROS, we need to check in a different window, because ROS is a specific window that pops up. Because we are in a web environment, we need to use this graphical tools section. So select graphical tools, and if you get this message, click on start session, and let me see here, you should see here ROS. Okay, then what do we have here? So the first thing that we need to change here is this fixed frame, because it says map. It is expecting to have the map merge, to publish into map. So let's select here, instead of a map, let's select here the robot 1 map, for example. So search on this system, on this list of frames, robot 1 map. Okay. So once you do that, you can see that a new robot has appeared here, and this is the robot 1, and then the robot model 1 is shown here, and here there are all the different maps for each one of the robots. They are unselected. Select the one from map 1 from the first robot. So this is the map topic of the first robot, and here we have this robot and the map that it is creating. Okay, so here you can see that there is another map. This is the map created by the merge. So the map created by the merge, it is published by the map merge into the topic called map, but we don't have map merge yet, so that is why there is nothing in there. So, and it's saying warning. Okay, so then we are doing this with the map 1, and we can do the same thing with the other robots and maps. So if I select here the map from the robot 2, what is going to happen? So nothing happened. So the map doesn't show. Why doesn't show? This is a very important question in order to understand how navigation works. It's not being published because the fixed frame is robot 1 map, and there is no transform between robot 1 map into the map of the robot 2. So if I open here robot 2 map, there is no transfer between robot 1 map and robot 2 map. So if we want to see this map from robot 2, let me close it like this, you need to come here to fixed frame and select robot 2 map. Okay, I can change it manually or select through the list of frames, and now you can see. So now is map 2, the one that is being shown, and the one in red is map 1. Okay, so that is very important point in order to understand how the map merge works. It's very important. What it means is that every robot is publishing its map in a different topic, but also every robot is publishing in a different global frame. So the frame for the map of robot 2 is called robot 2 map. Then the topic is also called the same way. Okay, that's not very fortunate name, but don't confuse, please, the frames with the topics, those different things. So let me know if you understand the difference between topics and frames. And here I see that somebody, Syam Ganatra, he's asking for the ROSject and ROS Agriculture that has shared. Thank you very much, ROS Agriculture. So my point was that you have to understand the difference between frame and topic, and how all the different robots, they are publishing in different topics with different reference frames. Let's have a look at that, okay? Let's have a look at that. So you don't have to trust me. So how do we see the different frames in this system with 3 robots and 3 maps, 3 different maps? So we can use a tool that is provided by ROS that is called the TF view frames. By invoking these TF view frames, we can see the TFs as they exist in the ROS system at present. So we are going to see all the different frames for the different robots and how they relate to each other. So let's go to tools. Let's have a look at those frames. Let's select the shell and then come here and type, when the shell allows you, type here, for example, is ROS run TF and then the words view underscore frames. View frames, view underscore frames. ROS run TF view underscore frames. So this is a tool that is very, very useful in order to debug and find errors in ROS. And with this tool, what we are going to see is which ones are all the frames that are published in the ROS system. That means how are all the frames that are published in the ROS system. And then we can see, we can have an idea of how they are related to each other. So now, when frames.pdf has been generated here. So let's have a look and let's view this frame by using the command ebins and then the name of the PDF, frames PDF. Ebins, then the name of the PDF that we want to observe, to check. Then a new window should appear here on the Graphical Tools, showing us the frames. Here it is. Okay, so if you go to the Graphical Tools again, where the RBase is included, so now you can see that a new window has appeared. Let me put it in big space, so as big as possible. And here you can see a lot of small things in there. Let's get closer to them. Fit to page, no, 50%, for example. Wow, that's a lot. Well, here you can see those are all the frames that exist in the current system, in the current simulation. And here we have the Robot 1 map frame, which is connected if we follow on this direction to the Robot 1 odometry, which is connected to the base link here. Well, the base footprint, Robot 1, and Robot 1 base link. Okay, so this is for Robot 1, and then below is all the structure of all the parts of the robot. Then what happens if we move to the other side is that we are going to get the same thing for Robot 3. You see, Robot 3 map goes to Odom 3 base footprint and base link, and the same for Robot 2. Okay, Robot 2 map, Robot 2 odometry, but none of them, they are connected. So there is no transform between the different maps. What does it mean? It means that those maps don't know what is its relation with the other two maps. So the robot 3 map doesn't know the relation in position between its map and the map of the robot 2. And the same happened with robot 1 map. Okay, so here is where map merge comes and provides this transformation. So basically what map merge does is to compute this transform between the one map to another. So what we are going to have is here a general frame called map. And this map is going to connect to all the 3 different maps by a transform. And then by doing this, all the 3 maps will be related to each other. Okay, I hope that this explanation is, if you don't know about TF, then I understand that this is a difficult concept a little bit. So let me see if there is any question related to that before we launch the map merge. Then here we have Jay Chucklin that says, yes, I have some years of experience with ROS here. Very good. Then you can follow. I'm happy. Jay Chucklin. Then Cash Reto says, hello, Ricardo, sorry for late. Okay, go to the back of the room, get the ROSject and start practicing with us. No problem if you arrive. Then Jay Chucklin says, can you use that with a static map? What do you think? What do you mean about a static map? I don't know. What do you think? What do you mean? Do you mean that there is a different map server per each robot? Is that what you mean? Map server. Yeah, okay. So Gimnet says map server. Yeah, it could be. Yes, you could do it. But yes, so you want to use an old map. Yes, but the purpose here, you can use it, of course, because the principle is the same. It's the same idea. Then the thing of using this with a dynamic map that is being built is because we want those robots to cooperate, so each one can be in charge of a certain area for exploration, and then we can create a map of the whole environment faster because there are 3 robots that are exploring, everyone take charge of that. That is why using the live maps, the G mapping, the maps that are built. But if you want to use this with a static map that you know the transforms between the 3, then you can publish those transforms. You don't need actually the map merge, because if you know the transform, that's okay. If you don't know the transforms between them, map merge can help you. Yes, it can help you, but it will be a one-time calculation. It will be just a one time because they are static all the time. You can use Jay Chucklin says, for example, you want to use an old map and you want to update the map. Yes, that is correct. You can use that for that, but then you will also need to create, okay, update an old map. That's difficult. That is difficult. Yeah. No, okay, so no, I'm thinking, okay, I'm thinking in terms of ROS, okay? In terms of algorithms, you can do whatever you want, but in terms of ROS, you cannot preload a grid map into G mapping, okay? You cannot do that, at least that I know that this is not a feature of G mapping. So you can only load it into the map server, and the map server is not able to modify an existing map. So not possible to update an old map. Not possible. You have to have the G mapping working all the time, or you create another program in ROS that uses those concepts. Okay, but as far as I know, for G mapping is not possible, and map server is static, so it's not possible. Okay, so let's continue. Then let's launch now the map merger. So keep in mind this picture about the different maps, and now let's close this one because we are not going to use it anymore. And also come here and you can close this program. Okay. So the program that was launching the mapping and everything and the move base. So now let's go back to the code and activate this code that is about the map merger, the merge of the maps. So this merge of the maps, it's a package that is called multi-robot map merge in ROS. It's this one here. Okay, so what we have done here is just to download from the Git the code, and then this code you can find it here. Is this one here. So you have here all the code and then yeah, so the one that we are using here today is the map merge, not the explore. Is this one here, but we have to apply some patches manually and recompile everything. So everything is being already modified for you by us. So the code that you have here, it's a little bit modified from the original here, because there was a problem in publishing the transforms. So that problem, we solved that problem, but still we have another problem. So let's go to this first problem that we solved, that is about publishing the proper transforms. Okay, so that's what we modified in this code, and you got this code already here working on this sense. So for that, now it's ready to be launched by using this map merge launch. And then the launch file, let me show you the launch file, which is included here in multi-robot map merge. It's where is it? Let me see. Multi-robot map merge. Where I cannot find it. Okay, so where is it? Multi-robot. Okay, let me check. Where is it? I cannot find it. Sorry. Okay, this is map merge. Experiments. Okay, let me see. So here I can see that there is something that is strange. Let me see. Okay, yeah, I can see now the problem. So the problem is that the package is called multi-robot map merge, but the directory is just called map merge. That's why I was not finding it. Okay, so but just by checking the package XML, it's okay. Okay, so this main launch, it's launching this map merge, that is this one, and what it does is just launching the map merge with some configuration here of the proper topics. And what we are configuring here is first the robot map topics. So we know that all the robots, they are going to publish on a topic called map, but map with a prefix. This prefix is the one that we specify in the robot namespace here. Okay, and this prefix is robot and the score and a number. So that's what this map merge is expecting. If we go to a terminal here, to a shell, and then we select here and do a ROS topic list, we are going to see here that, we have a map topic for each one of the robots. Well, actually not now, because I have closed the Gmapping, okay? But as you can see, for each robot we have a prefix that is called robot underscore and then the number. Robot 1, then robot 2, and robot 3. Now we don't have the map because it's not, the map is not running. That's why. But this robot underscore and the number is what we have to specify here as robot namespace. Then here you have to specify what is going to continue. It's robot, for example, for robot 1 is robot underscore 1/map. Okay. And also you have to indicate the robot map updates topic. So this topic is robot underscore 1/map updates. Okay, so that's for each robot. So this map merger is going to take charge of discovering any map topic that you have that starts with robot underscore and a number and then slash map. So you can be adding new robots at will, live. So the system is going to rediscover new robots if they appear while the system is running. That's very cool and very powerful. Then here you are specifying in which topic the merger is going to publish the merge map, so the whole map. And is this one? We selected map. It's just slash map, okay? And then what is the frame that we are going to use for publishing the map? The frame, remember, is the global frame that is going to relate all the other map frames for each one of the robots. So you are going to see there is a transform between this frame and all the other robot frames for the maps. And finally, this system can work in two ways. One is when you know the initial poses of the robot. For whatever reason, you know those poses, and then you can provide to the robot. I know that this is very difficult in real life, so that's why we selected false. Then when you do this false, the system is going to try to match the different robot maps. So it's going to try to figure out the relation by itself by using a scan matching algorithm, a scan or mapping matching algorithm. Okay, so it's a little bit more complex for the algorithm, and maybe it's not so good results, but it's more real life prepared. So I think it's closer to reality. So that's why we selected false. So that's it. Let's go and let's launch again this main launch file, and it's going to launch the merge. So again, the same file, ROS launch, Turtlebot, RTT exploration, main launch, and there we go. So that is going to take a little while. In the meantime, let me go to the questions. Then I don't see any other question. Any other question? Drinking some coffee? Is it everything working for you? Okay, so everything is working, it looks like, and also in my case I can see on the screen that map merging has started. Now what happens? We should see here the RBS appearing, and there it is. So let me switch to the graphical tools that is there, and let me put it in the as big as possible. So what do we have now? We still don't have, so we should have here all the transforms to the robots. So we should see, but it's taking some time. Okay, so it's starting to work and publishing the transfers and the different maps. So now here we can see here one topic. There it is. Okay, we got it. So as you can see, everything is now shown. What does it mean? It means that there exists a transform between the map fixed frame into each one of the robot models. So that transform does exist, and we are going to see it. So before we check the maps of every robot, let's go and let's launch another terminal, another shell, the one that we have before, and then let's do the same thing. It's ROS run TF view frames. So if we do that now, we should see that there is a map on top of all the other maps, robot maps, frames, that is connecting to all of them. Well, I know that it's happening because the robots are displayed on RBase, and in order to be displayed in RBase, they need such kind of transformation. So I know that it's going to be shown there. Also because I prepared the exercise before, so together with Christian, so that's why I know that it's going to happen. Not so clever, not so clever. Okay, so then let's go to the frames has been generated. So let me check with Evin's program. Let me check how it looks like. And there it is. We see, let me select 50%. And let me move to the center, because we are going to see this better on the center. If you remember, on the oh, okay. So that's strange. Okay, let me see if we are opening the proper file. Are we opening the proper file? Okay, so that should be an error for sure, because that makes no sense at all. And let me check if there is a map around here someplace. Let me check. Adam, maybe it's hidden somewhere. No, that makes absolutely no sense. So there should be a transform that is called map. I think that this is open in the previous file. Let me see if I can refresh. Let me close, and that makes no sense at all. Okay, so I don't care whatever this program says, because it's not. Let me see, ls frames, yes. So let me remove it and let me generate again. Okay, there is a message that it's unable to use this. Okay, sorry, I launched the wrong command. First, before doing the events, I have to launch the TF view frames. Okay, so now what it's doing is creating the description file with all the frames, the different frames. And yeah, let's have a look. It is generating. Let me see if you have any question in the meantime. Then their compute says maybe you need to RM the frames. Thank you, their compute. Already did it. Great, let's go. Let's launch again. And oh, sorry. No, wait, not that one. Events. And let's see. I can see that this is still open here. So I don't understand why it is doing this, because it makes no sense at all. So we can do another test that, oh, maybe it's because it takes longer. Oh, I know. It's because of the delay here. It takes longer than 5 seconds to publish. Yes, that's it. It's because it takes longer to publish the transfer between map and the other. It's probably is that. So let's have a look by using the terminal and then do a ROS topic echo of TF, and then we do a grep. So we are going to do a grep for map /map. Okay, so and let's see what it happens, what it shows. So we should see this. Okay, so that's not okay, but there it is. So we see here that there are some transforms, some frame IDs from robot 1, robot 2, robot 3, and then we have another one from map. And then what we can do is to, after let's say 3, and then before say 3 also, so we can see the lines before and after of this frame ID. Okay, so now let me see. Yeah, we have it. So what is this that you can see here on the screen? This is the TF. The TF is the topic that is publishing the different transforms that exist in the system, in the ROS system. And then what I'm checking here if it exists a transform between map and any other of the robot maps. So let me see, and here I can see that it's being published. Yeah, otherwise RBIS could not work. So, but I can see that it's here, the frame ID is publishing from map to robot 3 map. You see, here is the transform, and here is the transform being published from map to robot 2 and from map to robot 1. So this transform exists. Okay, so sorry that it didn't work on events. I will check later if it's a matter of the 5 seconds. You know that TF view frames is using a 5 seconds listening to the topic. So maybe is that the problem? Well, anyway, we have that. Let's go back to ROS and let's check the other map. So we can see here the general map. That's a map that is generated by the merger. This is the map generated by the merger. That's the one that we can see here. And if I unclick this one, it will disappear. And then if I click it, then this is the one from the merger. But we can add the other ones, the parts created by each one of the robots. You see, that's the map created by robot 1. That's the map created by robot 2 that is there. And if we unpublish the other ones, it will be easier to see. Okay, so that's number 2. And that's number 3. So theoretically, see, if we publish 3 of them, then theoretically we should see that the map topic is publishing something like those 3 together. But the problem is that we don't see that, and we don't know. That's a point that we have reached today. Until the last minute, we couldn't figure out what is the problem, and we suspect it's something in the code itself. So it's something that is not working properly in the code, and we are going to find it and fix it for the next live class. So that's a situation. One interesting thing that you can do here, so that's a merger part, is to move the robots. If you want to move the robots in order to make them build better their own maps. So how you can do that, that's the final thing I'm going to teach you, is by sending a navigation goal. But you have to configure this for each specific robot. How you do that? By doing a right click here and then selecting tool properties. Then let's assume that we want to move robot number 1. Then you have to go here to topic and select here the topic, go to the beginning of the topic, and you have to add there, you have to add, let me see, slash, okay, so I cannot write, oh, it's writing in the Control F, sorry. So, okay, so it's here, so for some reason I cannot write from, no, so it's kind of conflicting with something in my computer. Yeah, it's kind of looking for. Okay, so well, then you have to write there robot / robot_1, and then also you have to change here the fixed frame by typing / I don't know, I was just writing it a minute before and I don't understand that. So let me see if I can. Okay, so I don't know what happened, just enlarge the screen and now it's working. Okay, so let's go. Then you have to indicate that the fixed frame for that specific robot, for that specific navigation goal, is robot_1/map. So you have to select that one, and then also here on the topic for the navigation goal you have to include the /robot_1. Okay, now you are able to click on the 2D navigation goal and then select a point in the map of the robot 1 that you would like to investigate. For example, here looking into that direction, then the robot should start moving. If I have done everything correctly, yes, it's moving. It's very slow, a lot of stuff running. You can see my CPU is 100%. I mean, it's the CPU of the virtual computer in the cloud. But you can see that the robot is moving there. If we go to the simulation, we can see the robot better moving. It's one of those. Let me see which one it is. Yeah, it's this one. This moving super slowly. Super slowly. Okay, so that's what we have. Repeat the same process for all the other robots, and then you will have all the other robots moving around and updating the map. like this. So that is all for today, guys. So I don't have much more to explain you here, and this is because yeah, we have this problem that the map merge is not actually merging the maps. It's doing the transformations, and it looks like the transform is more or less okay, but we don't have the actual map merge. So please allow us to do that for the next live class. So on the next live class, we are going to learn how to solve that problem, and also how to activate the exploration. So we'll have now the full system with multi-robots working. Many robots simulated, many robots doing the mapping, each one by itself. Many robots using the exploration, moving autonomously and deciding where to go in order to identify the map. And finally, another node that generates the global map. So that's what we are going to have on the next live class. And that is all for today. And related to the t-shirts that you asked me, so let me show you the link where you can find those. Just a second. It's Teespring. So in Teespring, we have created a series of different t-shirts, like this one with the message that I am a ROS developer. There are different colors and different styles, different drawings, but basically the message is the same, because I mean, I am proud to be one of the few ROS developers that exist in the world, and I would like you also, if you consider yourself one of those, then I will also be super happy that you feel like that. Then in case that you want to have that, let me see, I'm checking here the link, and let me see if I can provide you this link. In the meantime, you can put some questions on the there on the chat, and I will answer them. Okay, so go for it while I'm looking for this for this link. Let me see. I cannot find it. Let me see. Usually I put this link at the end of the notebook, but today, so the notebook is not very good. So you have more explanations on the notebook, and some pictures and some images about what you are expecting to have, and some explanations, the same things that I have done. But I didn't have the time to prepare everything in a very clear way with all the messages that I wanted to show you. So questions? Do we have questions? So then let me see, just a second, Alberto, just a second. Maybe you need, so Hampelstein says patient, the TF is not updated very often. Yeah, thank you. That's it. Okay. Then they're computing my frames. There are maps connected together in map. That's good. That depends on how fast is that computer. And then I suspect it is that. And then Jochelin says that you can see the RB is the TF3. That's right. It's there, the TF3. So you can see it. And it's another way of seeing it. Very good. Then Hampel Steve 2 says and select map 1 and 2. I don't know what you mean about that. Your J. Chocklin says, thank you, Ricardo. It was an interesting event. No more questions for now. Okay, my pleasure. And then Gonfi has, actually Alberto has indicated the link where you can find those t-shirts. And yeah, so that's one. I think that you can select the different colors. The white one is not the best that I like the most. That's why mine is in this cafe color. Can you think why I selected the cafe color? Yeah, okay, so you got it. Any other question? ROS Agriculture says thank you very much. Are you Matt? ROS Agriculture, or are somebody else from the team? Let me know. Let us know, because I mean, we cannot handle that tension here. Yes, Matt. Okay, very good. Nice to meet you, to see you here on the live class. Great. And what about the others? So if you have more questions later, then let me know on, I don't know where it's going to be there. Oh yeah, so we are going to publish this video on the YouTube anyway. So in case that you have more questions, you can go there on this on this video and put them there. Or finally, you can also even send me a message. Let me give you my email, and then I will try to do my best. Okay, so I try to do my best, but sometimes it's a lot of work what you are requesting me, and then I cannot handle so much work. And then I will give you some indications and directions, of course. That's always, but I will try my best to help you with that. So that is all for today. Please meet me next week again on the same channel. We are going to send you the link for this Twitch, and it's going to be better. You know, we are always moving like that, going better, until excellence. So that's it. So thank you very much, ROS developers, and see you next week. Until then, keep pushing your ROS learning.